Okay, guys, so this is our second video of the 7.2 decomposition and conservation lab. Okay, so now we should have our data tables drawn. We got an idea of what we're going to do. So now we're going to actually collect some data so we can get some results. So first step in this, it talks about getting the mass of our Erlenmeyer flask and our balloon. Okay, so that's what we're going to do first. So I'll do the balloon first. And again, this is mass, so we're going to measure it in grams. So make sure we include our units. So the mass of our balloon is 2.8 grams. So go ahead and pause the video, write that in your data table. Okay, now we'll do the mass of the mass of our Erlenmeyer flask. Okay, so our Erlenmeyer flask weighs 123, so 123.7 grams, 123.7 grams. Okay, so now we got those. Ooh, I need to write those down. Handy dandy paper towel. So now we know the mass of our flask was 123.7 grams, and then the mass of our balloon was 2.8 grams. So now it's very, very important again that we are going to be subtracting the mass of this or our flask or both for any measurement that we put down in those second two data tables. Okay, so now the goal is we want to figure out how much mass do we have in reactants. And so our two reactants again are our baking soda and our vinegar. Okay, so let's do the baking soda first. So this one's a little bit funky. So I'm going to stretch out the neck of my balloon here, make things a little bit easier. Okay, and then what I want to do is, since I already know the mass of my balloon, I'm going to use my paper filter to pour my baking soda into my balloon. And then that way I can just subtract away the mass of the balloon, leaving me with just the mass of our baking soda. So we'll go ahead and do this. Pour it in there. We got some chunkies. Got some chunky baking soda. That's not good. Let's see here. See if we can get it to kind of filter in there. There we go. Okay. Now, again, in the lab, it says we want 8 grams. But the thing is we just want to know exactly how much we have. Okay. So when I put this on the triple beam or on our digital scale, it goes to 10.1 grams. Now, again, we want to subtract our 2.8 grams from that, okay? And that should leave us with 7.3 grams of baking soda, okay? We feel good with that. Okay, so go ahead and record that into the mass of your baking soda, or it should be NaHCO3, okay? So now we got that. Now let's do the mass of our vinegar. So it says add exactly 100 milliliters. So I'm going to use my graduated cylinder. We're going to pour our vinegar into here so we're nice and accurate. Ooh, hopefully I have enough. Oh, don't have enough vinegar. That's okay. So I have approximately 92 milliliters, and that's okay. So as long as we know the mass of it, what did we start with? That's more important. Okay, so I just added it to our Erlenmeyer flask, and now we're going to put it onto our triple beam balance. Okay, so let's see. So now our total with the Erlenmeyer flask and the vinegar is 216 grams exactly. So let's use our calculator here. So we're going to take 216 and subtract our mass of our flask, which was 123.7. Okay, so we should get 92.3 grams of vinegar. Okay, so that is the mass of our vinegar. So go ahead and add that to your data table. Okay, so now, next step, this is the exciting part. So as we go through our procedures, it says, okay, take the balloon, we're going to stretch it over the neck of, or the mouth of our flask. Okay, just like that. So now we're ready to have this reaction take place, okay? And so basically now we have a way to trap all the gases that are produced as well as any of our products that collect down here. So we're gonna go ahead and dump that in there. Wow. And it says swirl it. Oh my goodness. Okay, So we can see the balloon's inflating because it's filling with carbon dioxide, right? So one of the things that we talked about in our previous labs was indications of a chemical change or a chemical reaction anytime we see bubbling or fizzing, because we know that gas is being produced, okay? So we'll let that kind of react. Another kind of cool thing we'll talk about is with reactions, they either take energy and require energy, or they release thermal energy. This one, the flask is getting really cold. You can kind of feel the balloon as well, meaning energy from the outside is being absorbed by this reaction, and that's causing it to cool down. Okay. It's kind of a weird concept, but that's called an endothermic reaction. So we can think of it as the thermal energy is going into the reaction or being consumed by the reaction. Okay, so we're going to keep doing this until we got basically all of our baking soda dissolved. So feel free to kind of fast forward the video a little bit if you want. Okay, I'm going to pause this for a second so you don't have to watch that long. Where's my mouse? Okay, so now a few minutes later, I've swirled the liquid around so we can see that we no longer have any baking soda in there. When we swirl it, very few bubbles are being produced. So now we know that that reaction is basically complete. Okay, so now next step is down below. It says, okay, measure the mass of your Erlenmeyer flask with the balloon on there, all your products inside. So we want to get our total mass. Okay. So again, so we got 224 exactly, so 224. Now, again, that mass, that is accounting for our Erlenmeyer flask as well as our balloon, which we don't really care about. So we need to subtract our initial 2.8 grams from the balloon as well as our 123.7 grams from the flask to get our actual mass of our total product. So let's do that real quick. Okay. Okay, so after we did the math on there, we should see that we have about 97.5 grams worth of CO2 and our other product, our acetic acid. I think maybe that might be wrong. I might be lying. Which when we look up top, that looks pretty close, right? We said we had about 7.3 grams baking soda and 92.3 grams of vinegar, so we're pretty close there with that total. Okay, so now the next step is we want to be able to just say, okay, how much CO2 gas was collected? So now we need to remove our balloon, and we want to try and do that without releasing any gas. Okay, and we're going to get the mass of that. So to do that, take it, give it a little twist here. Okay, and then now I can remove this here, and you can hear that little bit of pressure, right? So there's obviously going to be gas collecting in the neck of our Erlenmeyer flask, so that could be a source of air. Okay, so now we got the balloon tied off. Okay, we're going to go ahead and just put that in here. Now another thing we can see, I don't know if you guys can see that, there's a little bit of liquid in there on our balloon. That is going to skew our results a little bit, but we'll do the best we can here. So now, see if we can get it to stay on our scale. Oh. Come on, you booger. Too staticky. There we go. 4.7. So again, so that's going to be 4.7 minus our initial 2.8 of our balloon mass, which is going to give us the mass of, what is that, 1.9? 1.9, okay? So that 1.9 grams is going to go into the mass of our CO2. So then we want to figure out, okay, well, what's the mass of our liquid? So we can just take that total mass, 97.5, subtract the mass of our CO2, our 1.9 grams, and that's going to give us the mass of our liquid product in here. Okay, so go ahead and do that last piece, and then hopefully this will help with our conclusion, our analysis, and our synthesis question. So the analysis questions just are saying, compare the mass that we started with the mass that we finished with. knowing the laws of conservation of mass, we should be pretty close. Now, obviously, if we're using things like balloons and things, it's not super accurate. So that can account for some of that loss. So that's what it's wanting you to do on the analysis. Then for the synthesis question, it's saying, let's compare our synthesis reaction from the last lab with the decomposition reaction from this lab. So that decomposition reaction, make sure we notice it's the second reaction listed on there, right? When we take, I'd have to look our CNaCO3, and we're going to break it down into H2O and CO2. Okay, that's a lie. COH3, and break it down into H2O and carbon dioxide. Okay, that we can see it's getting something complex, and we're breaking down into a simpler product. Okay, so it's kind of the opposite. So that's what it's wanting you to do there. Make sure you include those reactions. Okay, all right.